That was the good message. We go live, and you said now. Okay. Hello. Very good morning here from Germany. Very good afternoon to you in Singapore, Jensen, to our new webinar series, Mastering Probe Transportation. Great to have you on board here, Jensen. How is everything in Singapore?
Wow, it's remained hot and sunny, but it started to get rain now.
All right. Oh, is it?
High
Okay.
humidity.
Okay. I can tell you today is a super froggy day here in Germany. So yeah, I think that is slowly the preparation of the next season, which is currently coming. But we had a super nice October so far, so we cannot and should not complain. Okay, Jensen, as always, we are very short on time. I mean, we take this chance, and oh, by the way, super, Mr. Mena, our Antonio, our trustful friend and partner from Brazil, it says hello and very good morning from Brazil. That is, yeah, incredible. At what time he really wakes up and is attending this. I also want to thank at the beginning already my dear colleague Jonas, who is supporting us here from, let's say, the background, and will share some very good and interesting information for you guys. Because today is something special and something we would like to highlight. Mastering Probe Transportation. James, what do you think about this title?
I always felt that the word mastering is an area that only a few of us, only a few companies deserve using this word. One of them is ourselves, definitely. As being an original manufacturer, there are so many things to share.
Okay, yeah, yeah, okay, yeah, that's also an interesting view on this topic. But maybe let me explain why we changed this a little bit. In the past, we would always call this like heated sample lines and different types of heated sample lines or tube bundles. But at the end, it is the solution we would like to highlight here. And we just want to show that probe transportation can make you some headaches, but it can also be easy. And we would like to give you an overview, even if the topic itself is relatively complex, that yeah, the solution is there and that there is good solutions available. Okay, allow me to highlight also our next and let's say final session this year in 1 month's time. James, I need to see, I think I'm in Helsinki on that day. Hopefully traveling back at that time, but yeah, I'm excited to have this last session, which we call the probe conditioning, as the heart of the sample handling system. And I think a lot of information we can also share on this topic. Yeah. Okay. So, but let's not waste too much time here. Allow me to highlight, Jemsen, as you are covering the Asian region, also to show our dear colleagues the contact data are available on our website. So this is Jose Luis, who is handling the Middle East area, and also because he is from Spain, he's now also supporting us in Spain. He recently just joined the SEM conference together with Thorsten in Barcelona, which was a great success with many talks and yeah, many nice feedback for us. That is always very good to get the direct feedback from the end user, from the customer, from the system integrator. And obviously the guy I've been already mentioning, Antonio Mena, who is doing a great job for us in South America. So yeah, this is our world team, and do not hesitate to contact them, to contact me, to contact us if there is any inquiries, any questions, anything you would like to know or to discuss. Okay, yeah, Jimson, I think from a basic point of view, from a theoretical point of view, the topic for today is very easy, huh? we just have to bring something from A to B.
Oh, that is the most underestimated, which has shares the biggest surface area in the complete sampling system. Anything can happen during the journey.
Yeah, that's obviously true, and that is the reason why I like this topic so much, actually, because I would fully agree with you, Jensen. I think the probe transportation is something very much underestimated, because I mean the application itself is really to transport something from A to B, but there's so many mistakes and yeah, so many problems which can occur. And I would say very experienced people who are doing this, um, yeah, would agree to our statement that do not underestimate the transportation, and that is for many reasons. And the reason, and this is also something we would like to show here before we give you a brief overview of our today's agenda. By the way, any contacts, if you want to contact us, Jonas was so kind to post in a comment here an overview of our contact persons. Thank you again, Jonas, for doing this. And that helps us also and the community out there to get the right link and the right idea. So maybe really, Jameson, we start with the inside of the probe tube before we then, slowly discover, uncover, yeah, the different applications and also the complexity which can end up in a heated sample line. And I think we can give a very good overview. For me, it's also important. It's always important. Our yeah, let's say another favorite topic is the ATEX area, the ATEX topic, the special technology we have been developing over the last years, and the special solutions also for our customer, because this is something which is safety and we believe in. We should also make this, let's say, part of applications more safe. I have a very special yeah, thing to share with you out there, and this is our first white paper. So what we've been doing with the help of Jemsen, with the help of the past webinars also, and with the content of this, we've been putting together all this information, which is mastering gas sampling transportation. And I would really, as a special, let's say, gift for you guys out there, it is a free copy of our white paper. It is not that you have to read like for hours. It gives you a very good overview. We try, I mean, we've been exercising this to make this very compact, to make this very easy, and at the end, to have a small checklist which allows you in your project to check, are you considering all these facts? Are you considering all these requirements in your project? And if so, you will probably have no problems in your project with the topic of gas sampling transportation. Jonas, also here, again, thank you so much for sharing this link and sharing this information. So this is the way how you can download the white paper. And yeah, if any questions to that, again, do not hesitate to contact us. Okay, so oh, wow, we always have to yeah, be very fast as we reduce the time now to the 30 minutes here. Jemsen, the probe tube inside. What would you say? What is the yeah? Let's say. I mean, when we talk about SEM projects, continuous emission monitoring systems, I would say 99 plus 9% is probably PTFE or PFA, right?
Yes, yes. I think one of the area that I like to stress, whether we are using the seamless stainless steel or we are using PTFE or PFA, one of the things that that makes us different when we use the English word terminology like stainless steel. What is it all about? I want to stress this word to the audience is that to us, we call this the analytical line. All right, that means we have taken into consideration about the number of pits, the number of, the porosity inside this tube. Right, it's so important that those are not the tubes that you can find, out from the hardware shop. Yeah, a lot of people has
Yeah,
mistaken them.
yeah, yeah, and that can already be the first big mistake, let's say, Jemson, because funny fact, the surface of the heated sample line in many systems is the biggest surface to the probe. And I think we always have to consider what is the consequence out of this. That means if you the surface you present to the probe can affect the probe, and that is exactly what we do not want. So the task here is to have an unchanged in exactly the same condition, like we have been taking this from the gas sampling probe to the analyzer, maybe to the cooler, depending on the conditioning system and depending on the analyzer technology. So again, sounds super easy. Do not change the probe, but in fact, it is not. And what we would like to show here, just to give you an overview, is depends on, are you in a SEM system where you would suck the probe from the stack, for example, or are you in another application where you have a positive pressure on taking the probe, and then you might need to use more pressure resistance items like stainless steel, Hastelloy, Monel. You can see out of the list just the different type of tubes we are using. And I think we do not have enough time to cover all of this, but I would like to remind you, we had a webinar specifically about the topic of coating and covering surface treatment to the inside, to the stainless steel tubes. And I would really like, if you have any questions on this, we are working with the company Silcotech, and that is an overview from the company Henkel. We are also in a cooperation with which really shows what is the advantages of silicon covered, of electro-polished, and maybe even of the combination of silicon covered and electro-polished. And I think that really gives a very nice overview and helps you also to choose the right solution for your application.
Mhm.
Okay, we've been talking about the tube itself, Jensen, but sometimes we also have the situation that there is multiple tubes, and I must tell you, maybe it's not so common in the region where I'm currently sitting in the Europe region or in northern regions, but in the region where you are, very often you don't need a heating. Yeah, because there is no freeze, there is no, you will not see negative temperatures. So, and in this case, it might be also sufficient just to have an insulated tubing bundle. And I would just like to show here what a tubing bundle looks like. And I mean, that is a very massive version, Jameson. Maybe, yeah, sometimes in the field of instrumentation, but can also be used in the analytical field, where in this case now we would have, I don't know, I think it's even 9 or more tubes in one bundle. Just to show you the technical possibilities. And from this base technology, meaning we can take not only one tube, but even two tubes, yeah, we can develop to a heated tubing bundle, or as you said, maybe the better word, Jimson, analytical line, right? Which has a tube, one or more tubes inside, which is insulated and electrical heated with a tracer, right?
Yeah.
So
Yeah.
that should just give probably a very good overview.
Mhm.
Okay, when to use what? I also think, Jemson, it's important for us here to give our audience, let's say, the
Mhm.
most
Mhm.
outcome out of this.
Yeah.
And um,
Yeah.
the seamless tubes, for example,
Mhm.
you have the chance. I mean, when you have straight lengths, it would be 6
Mhm.
meter tubes, and you have to
Yeah.
connect always with a fitting. That
Yeah.
is more effort in terms of costs, that is more
Mhm.
effort in terms of installation. So it's
Mhm.
easier to take this from a coil, right?
Mhm.
And if you can imagine in many applications where you have test gases, for example, calibration gases, where
Mhm.
you have to
Mhm.
transport maybe also liquids or something,
Mhm.
it's super efficient to use a tube bundle, yeah, with more than one tube.
Mhm.
And yeah, at the end, then really, when we are in the application of analyzer application, heated tubes or heated bundles are the right solution
Yeah.
there. Okay. We do not want to confuse you. We just want to show you our possibilities. And therefore, I can say we try to make it easy to work with us, easy to find the right solution. And Jimson, we have this configuration matrix, this match code,
Yeah.
how we
Yeah.
call it.
I think one of the audience must understand that why the configuration matrix is so important for us, because being the heated line manufacturer, there are many consideration, right? Because at the end of the day, as a user, you want the sample to be representative from point A to point B, right? Point A come
Right,
from the tap-off point, and point B is where your analyzer. So along the journey, all this metric configuration, we have taken into consideration about, you're right, not only the smoothness of the material, but you
right.
see the absorption, the desorption, the memories effect, the losses. All right. So in order to have this, all these things, right, we're talking about the journey. At the end of the day, in the analyzer, we talk about the response time, the T90. So it is a factor that this metric is so critical when you wanted a really good analytical line.
Yeah, yeah, that's true. And it should help you to have a good system and a good structure to select the right solution for your application. Yeah. I also posted the link to the match code for the heated sample lines so that you have an overview of all the different configurations which are possible in our system, right? So that everyone is alone is aware of this. Okay, wow. Jimson, the big field. I have to put away this it's very heavy, I must say. It's very robust. I mean, it's for industrial applications. Maybe you can give a brief overview of these two different types of heated lines with the flex and the extruded. How we separate this, Jimson?
Yeah. Yeah. So being saying that we have so many types of configuration, but right in the field where you are doing or you are buying the right type of heated line, we always have to remember that how long can the heated line we can the length given the fact that you only have a single phase power supply. All right. And we have to calculate the wattage. And it is easy to run sometime on the cable tray, but what about those considerations like entering into the analyzer house, such a constraint, right? What about the banding radius? Okay, Yeah,
Yeah.
and therefore, not only the general purpose, we talk about ATEX, all right, ATEX 120, ATEX 150, ATEX 180 degrees, right? So, if only if we have a Q&A, we hope so, we can able to answer more interactive session one day.
Yeah, that's true. That's true. Okay, but in general, we must say the left side, the flex side, is maybe more or less something like a standard, I would call it, Jimson, in the SEMS world. Yeah, for CEMS systems, yeah, you might use the flex line or the extruded line. The big difference, like you said it here, Jimson, is the left line you cannot cut, yeah, and the extruded lines you have the possibility on site to cut this to the right length. And maybe our new product, Jimson, really shows, yeah, the possibilities and also the capabilities here from our company and from our development team and also the production. We've been, let's say, yeah, introducing this new product in at the SEM conference in Barcelona, and like we said, the reply and the response on this new product was impressive. What is this? We call it the new Duo. And the new Duo is a combination of an extruded line, which you will find here, and a flex line. So that is, let's say, the best of two worlds. Why are we doing this? Relatively often, you have the situation that you either have two probes which you want to two sampling points or 2 points at the probe which you want to connect. And I mean, we've been saying that in many webinars that if there is a cold spot, that can already result into bigger problems, right? So this is the possibility we have here with this new product is you can connect two lines and it's completely heated. It is heated here and it is heated here. And you could even have the configuration down to the analyzer. So when you have the situation that, let's say, one probe is connected to two analyzer, you would not need to install two heated sample lines. What you can do is you can select the Duo line and you have the flexibility up here, completely heated, 180 degrees C. Yeah, it's a relatively easy way to split it. So this is, like I said, extruded here, flex here, and maybe a very good example to show how we can kind of play in these two worlds and how we can combine the good advantages of these two worlds, right? So, okay, regarding the heating, maybe also important to say, because the heater of a heated sample line is like the engine of the car. Yeah, if you have a very shitty engine, you will never end up in a good position on the racetrack, right? And so this is the reason that our heater technology is established for so many years, and there is no uncertainty, let's say, if the line is heating up, if we have a homogeneous heat transfer to the probe. So this is something I would say very important. Together with our partner Raycam, we even have the chance to offer 10 years warranty for the heated for the tracer itself, and I think that is really a very rich and a very quality package what we can offer there. So if you are able in your project to cover the requirements and the challenges for probe transportation in a safe area, you're already good, I would say, Jimson. Don't you think?
Yeah, yeah, yeah.
Yeah.
In fact, I just wanted to contribute one of the application for the the separated lines. In many occasions, where in some countries for the SAM systems, now more and more they are measuring VOC. All right,
Right.
the VOCs are not allowed to go into the gas cooler. So whether the V is up at the sample probe, all right, they were able to split into one to the gas cooler to the infrared analyzers. The other one actually goes direct to the FID for the VOC measurement or total unburned hydrocarbon. This is
Right.
actually a big saving for the industry.
Yeah, that's a good, very good advice. By the way, let me just show here. This is Jonas was so kind to post this new PSG Plus extruded duo line, which I just presented, so that you know where to find it. Yeah. Okay, but Jemson, now the big requirements when it comes to ATEX, and we see more and more RFQs and more installations in the field of ATEX. So, what would you say? What are the special requirements?
I think there are the certification. All right. In fact, people nowadays we're talking about the petroleums. One of the biggest emphasis is safety. Safety,
Right.
safety, safety. Nothing can
Yeah.
compromise the word safety.
Yeah. True. This is true. Yeah. And therefore, I mean, we've been doing webinars about that, but I think we cannot focus or highlight this enough that it is a unique solution set what we can offer our customers in the field of ATEX, which is I would like to give really an overview here of our different ATEX solutions and different products, which you can also see in the slide and in the overview here. So we start with the ATEX line. This is the standard how we start here. In this case, it would come with a ATEX certified heating cable, right? This is probably step one. And then we have been developing even also for more than 10 years, I would say, the AX2 line, a very special line, which allows to be installed in ATEX areas. And it is also covering something which has not been on the radar for many years, which is the electrostatical load from the outside. Yeah, Johnson, you should also show this here, which finally ends up in the, let's say, the highest solution we have, that is an installation which can also be installed in ATEX Zone 1, which is the conductive, comes with a conductive jacket. And as my colleague Jonas did this super nice video, maybe Jemson, we add him here to the show to explain
Hello
us
guys, I'm
about
Jonas
that.
from PSG, and today I want to talk with you a little bit about conductivity, especially for ATEX areas, so explosion-proof areas. What you can see here is just a regular conjunction box. Here, over to my left side, you can see a conductivity meter. So just take a look at what happens if I put the conductivity meter on the conjunction box. You see that you don't see anything. So now my question for you, would you use such a conjunction box for an ATEX area installation? I wouldn't. Usually you use conjunction boxes like this one, specially designed for ATEX areas. What this means, could you see here? There is a conductivity on the surface. That means that unwanted static electricity can flow against the protective earth and isn't a risk anymore for your system, for your ATEX system. But pretty much the same goes for our heated sample lines. What you can see here is one of our usual PVC jacketed heated sample lines. We can also deliver this one with an ATEX heater, but this one would be with just regular non-conductivity. how you can see over here. So if you won't use just a regular conjunction box in an ATEX area, why use a regular heated sample line for the ATEX area? Instead, we would recommend to use our ATEX-3 heated sample line. What you can see over here, when you go to the conductivity meter, there's a fully conductive jacket on the outer side, and the conductivity even goes up until the cap, which you can see over here. So even the caps are conductive, and you can place these caps yourself. So you can cut it to length, or we can also place the caps for you. And even when you cut it to length, you have the full ATEX certificate for the whole line. So this would be one of our heated sample line courses, a little excursus. Thank you very much for watching, guys, and have a good day.
Yeah, wow. I think
wow. You know,
that
this
is
is
a
really
nice
a
video,
breakthrough.
which really shows the difference, right? Which really makes sure, you select the right one. We have to hurry a little bit, Jemsen. As we said, always or often underestimated in projects, and avoid these mistakes. I would like to highlight here again our checklist, which gives you an overview of what are the things you should consider in your project. Reach out for our world team, get in touch with Jemsen, Jose Luis, Antonio, and obviously Jonas, me, and the other guys from the team. And I thank you so much for participating here, and see you in 1 month's time when we talk about the gas conditioning. I'm excited and looking forward to it. Jemsen, thank you so much again for being here online, right? Bye-bye.